Okay, as you may remember, my flyback driver with the CFL ball didn't last very long, and now I figured out another way. I went to Radio Shack yesterday and got a 555 timer. I got a transistor, but it fried. I had a free sample of Texas Instruments MOSFET, and it fried. It only lasts for a little while, but I found this one that come out of a VCR. I believe so. It's part of the switch mode power supply, and it's waiting for the collector current, collector voltage. It's waiting, collector emitter voltage is waiting for 400 volts, which is kind of high, and it has 5 amp maximum on the collector. But if you pulse it, which is what we're doing, it can handle up to 10 amps. Now what I have here, I put a resistor, a 10 ohm resistor. It barely gets warm. It gets lukewarm. The transistor gets barely warm, and the 555 timer can't feel no heat at all. And it makes pretty big arcs. I do say so myself. For how powerful it is. Now on some transformers, you might have to switch out the capacitor in the 555 timer circuit to something a little higher, so it has a lower frequency. Because sometimes frequency can be, it won't work the best with it. I'm not for sure if it will work with a 10 nanofarad capacitor, but when I had it with that MOSFET, I found out it worked better with a 100 nanofarad capacitor instead of a 10 nanofarad capacitor. So I had this 100 nanofarad capacitor I got from Radio Shack. I thought it was a 10 nanofarad and got the wrong one, but it works anyway with it. We'll turn it on in a minute and you can see the sparks from it. The schematic is very simple. So a 555 timer, a stable multivibrator, which makes the oscillator a square wave. It goes through a transistor. The transistor switches the flyback's primary on and off to create a voltage that boosts the voltage up. These flybacks have to have kilovolts of, not kilovolts, kilohertz of frequency in order to work. I'm not for sure if the CFL bulb would be better. I don't know. Anyway, I'm supposed to get a ballast sometime. So if we get the ballast, we can hook it up to a ballast, and then it should, for one of those fluorescent lights, and it should be able to do better than this. Well, I'll turn it on. I have about 12 volts, and I'm going to turn the power supply on. Now watch. See, where is it? It's right there. Okay. As you can see, it's a pretty strong arc. And transistor doesn't get hardly warm. Neither does resistor. And it's only drawing like 340 milliamps at 12.3 volts. It probably drawing a little bit more than that. But the thing is, it's oscillating, so that meter can't tell us what current's drawing. You can't tell because it's oscillating real fast. Usually if you know what the duty cycle is, you can figure it out by that. But that's not really going to be helpful. Be very, very accurate. It's working pretty well. I do say so myself. And I believe it's going to be stronger than my initial coil power supply because it's a flyback. The flyback has more high voltage than what an initial coil will have. smelling the ozone layer, where they call it. Okay, I'll turn it off. Now I'm going to fill the resistor. Lukewarm, barely warm actually. Transistor, can't even feel any heat on it at all. 555 timer, no heat at all whatsoever on it. Of course, because it ain't drawn on the 555 timer, it's drawn on the transistor. It uses the transistor so the 555 timer can switch it on and off. So there we go. We're gonna get a good flyback drive with it. I may put a connector on here so I can connect it to different stuff, maybe RCA connector. So now I hook up to my ballast, so I hook to a ballast, I can do that. Oh yeah, another thing I should tell you. Why it's in this cup here, the soup cup, or we call it soup mug, what Dollar Tree called it. It's used for to hold the transformer in there, also hold mineral oil on the pin so they don't arc over to a different pin and ruin it. This is what the mineral oil looks like. I believe it does work. Some high V mineral oil is. I don't know if it's colors. The colorful is just fine. I don't know if they make them colored ones. I'm not for sure. Tasteless and odorless. Just pour a little bit in there. Why there ain't very much left in this bottle is because I have too much in there and I want to take some of it out. I pour too much in. Yeah, I make sure don't put too much in, otherwise it could do something you don't want it to do. It could short out the transformer or something like that. So what you do is you just pour it in there a little bit, enough to cover up the pins on the flyback. So that they don't arc over. At the bottom, they may arc over if they get too close together. That's why it's a good idea to put mineral oil in it. You could probably use vegetable oil if you wanted to. I heard about that. I was looking on Wikipedia at the transformer oil section, and they had stuff to talk about using mineral oil. And then they say you could also, because some transformers use mineral oil on it because it's cheaper than transformer oil. And also, some would say vegetable oil will work as well, as long as the voltages go over 230 kilovolts, which I don't think it will. That's pretty high voltage. This resistor is a 10 ohm at 10 watts. It could be less than that. If I do less, it'll probably do better. They need to put more stress on the transistor. I think it's good enough. We'll leave it at 10 ohms. Who knows? I might be able to one without that resistor, but I'm not going to take the chance of wiring it. So we'll leave the resistor there. Then when I turn it back on, there it goes again. $340 milliamps. But I don't think it's 340 milliamps. Probably a little bit higher, maybe double it or so. the way to lift it off of it. I'm not for sure. Probably I want to use that ballast. I don't know what's trying to use the 555 driver. Anyway, I'll turn it off and install the schematic. Okay, what we got here is a circuit of the 555 timer flyback driver. We have our transistor right here. It's a 2SC5130. Transistors you should really get this one, because otherwise you're just gonna have to play around with trying to find a transistor, and it might not give you the best results. So this one come out of a VCR. It was in the switch mode power supply, and it was like a 20 megahertz transistor. It probably doesn't need to be a 20 megahertz. Probably be less if you wanted to. Anyway, 100 ohm resistor, quarter watt probably will do well. I'm using a half watt one, so yeah. And resistors. These resistors do not matter. I just took this one off of a circuit I found, and I was going to use it with a 10 nanofarad capacitor. I tried it with it, and it didn't, and it sucked. Yeah, it sucked. It didn't get very much power coming out of it until I switched to 100 nanofarad, and then it got like lots more power. I bet it could be is because this transformer was not made to handle 26 kilohertz like what that circuit had. It's supposed to handle less. It probably can handle that. It'll just that it'll weaken the voltage because of the inductive reactance. They probably do that, probably because of the inductive reactance on it. That transistor will be able to definitely be able to handle it. With this transistor, it's so strong. It is such a strong transistor. You can use the 100 nanofarad. And that's why a lot of these transistors I tested with just broke. 555 timer chips right here. Pin 4, pin 1, pin 2 tied to pin 6. Pin 3 is the output. That goes to the transistor's base. Goes to a resistor, a 100 ohm resistor. And pin 7 down here, which goes to your voltage divider of the two resistors. And it's powered by a 12 volt source. It can really go up to 18 volts, but I'm not going to do it that high because I don't want to break the transistor. Then up here, you got a 10 ohm, 10 watt resistor right here. You could probably try it without it, but I'm not going to do it because I don't want to fly. It's good enough. The 10 ohm resistor just limits the current on it to about an amp. And it's probably not required though. You could probably try it without, but I would, if you do that, get two of these, so if you get one fails, you can switch it out and put the other one in. Because this will fail if it draws too much. The only thing that'll fail will be the transistor. Then right here's your high voltage output coil. Then your primary, this is your secondary over here. This is your primary. I like about this one, instead of the one that just uses just transistors, is that you don't have to wind the coil for feedback, which I forgot where the feedback coil is. It's not needed, just use the primary. This 1K resistor and 2.2K, that's what you typically you'll want on your thing there. You can use that. You can use different values. You can probably get out of the TV if you want instead of buying resistors. You can get a resistor out of the TV, then use it. I don't know about the 10 watt one. You might not be able to find that one. And then if it's in there, you probably have to, well, you actually take it out of the TV, so you probably can take it out of there and use it if it has it. Most TVs I had don't have power resistors like that. I did have one that had one like that. It was the old one. So with a 12-volt power supply, 555 timer, the 2LSC5130, and the instant transistor, I checked it up. I only found one person that sells a DigiKey. I don't order from them. And all electronics don't have it. If it probably had it, it'd probably be more expensive than all electronics. But DigiKey, you get it for $1.44 or $1, whatever it said it was. $1 and so many cents. So it's not that expensive. But you make expensive transistors. I heard about one that this one guy used for his high voltage power supply in it. It was had to have 10 amps on the MOSFET direct current on it, and they're very hard to find, and you have to get a certain kind. Well, I think that's about it for this video. So I hope you build it if you found this video interesting. So, may I get back on there so you can see the rest of the circuit. There's what the whole circuit looks like. Okay, so I hope you enjoyed this video. Thanks for watching. If you like it,